Hello guys, welcome to Code Design. And in this video, we will be discussing about the Catalan numbers. And basically, we will be solving. Basically, I will tell you how you can solve such kind of problems, and we will be deriving the final nth term formula of the Catalan numbers. And actually, when I was trying this problem, I could not find any good resource. I mean, you can search on Wikipedia about the Catalan numbers if you want. Wikipedia. So what you will see here is there are six proof like 1, 2, 3, 4, 5, 6, and I will be explaining this second proof. I think this is the one using the reflection line. And you don't need any prior knowledge to understand this except for the knowledge of the class 11th and 12th permutation and combinations. And we will see how we can calculate the nth term, how and you will see and you will see how you can derive this nth term formula for given any n, and even if we have some prefixes, and we will see how we can do that. Okay, so let's read the problem statement first of the first problem. Your task is to calculate the number of valid bracket subsequences of length n. For example, for n equal to 6, there are 5 sequences. So basically there are 3 open brackets and 3 closed brackets, and we want to organize them or make a permutation of them such that it is a valid bracket it is a valid subsequence, right? So what we can see here is like we have 3 open brackets. Let me use a black color for this. Okay, so we have 3 open brackets, not this one. Yeah, so we have 3 open brackets and we have 3 closing brackets. So how can we make a valid subsequence out of this? There is only one condition, that an opening bracket must always come after a closing bracket cannot come after the opening bracket, right? And if that is the case, then that subsequence will not be valid. For example, we can say that so this is a valid subsequence, and now I can't put more than the number of closing brackets before it. Or we can even say, like, suppose we have like this something sequence like this, then we can even say, like, I can consider this opening bracket as a +1, and the closing brackets as -1. So +1 +1 -1 -1 +1 -1. So if I take the prefix sum of this number array, then at any point of time the prefix sum should never be less than 0. It can be equal to 0 or it can be greater than 0. Both will work, but it can never be less than 0. This will give an invalid subsequence, right? And this is where the concept of Catalan numbers comes in. Actually, you can even calculate this using dynamic programming, and there is a better way to visualize this. I mean, basically, we don't want to cross we can't cross this, like, we can't go negative, right? So there is an even similar problem which solves basically the same thing. Like, I can consider so, like, if I consider my opening bracket as uh, a right movement and my closing bracket as a up movement. Okay, so I'm considering my opening bracket as a one move right to the right direction, and my closing bracket is one move to the up direction. What I can say is basically, so what I can say is I want to find the number of paths from, let's say we have three we had 3 opening and 3 closing brackets, right? So we want if my current point is 0 comma 0, we want to reach 1 2 1 2 3 1 2 3. So we want to reach this point 3 comma 3. Okay, but there is a condition that we can't cross this line. Suppose we are here 0 comma 0, focus on this graph for now. And we want to reach this point 3 comma 3, and we can't cross this line. We can touch this line, but we can never we don't want to cross this line. So there are several ways, like we can go 1 1 1, then one more, one more, one more. Okay. So this will represent my opening bracket, opening bracket, opening bracket, then closing bracket, then closing bracket, then closing bracket, right? So that is how we can form the number of sequence. And if I am able to calculate the total number of moves from 0 comma 0 to 3 comma 3, then that will be my answer. Now there are several solutions for this. I mean, using dynamic programming, you can calculate it in one of the ways, big O of n square, which should work for 10 raised to power order of 10 raised to power 4, right? There is also a there is also a DP approach of big O of n, so you can optimize it to reach a complexity of 10 raised to power 8, right? Okay. So basically, we want to achieve this complexity, and I will show you how you can do that. So for that, we just need to calculate the number of paths from 0 comma 0 to let's not consider a 3. Let's take a better example, like okay. Let's for now let's take 5 comma 5. Okay. So 1 2 3 4, not that one. So it will be this point 5 comma 5. So we want to calculate the number of paths from 0 to comma 0 to 5 comma 5, and we can make only two types of movement. Either we can go right or we can go up, and we never want to cross this y is equals to x line. This y is equals to x line, right? So one of the ways is to use dynamic programming, like I will just show you. So let me just change the color. Like how many ways are there to reach the point? So currently we can only go right, 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 right. And then I can say, okay, I don't want to go here, so there are no paths on these routes. Let me just mark all of them zeros. I can never reach these points, right? Because they are invalid moves. Okay. Now you can initialize a DP array of, let's say, n plus 1 into n plus 1. Okay. 2D array. And then, like, if you want to reach this point, you can either come from here or come from here, right? So the only possible move to reach here is 1, by going right and then going up. So the number of ways to reach this point is 1. Similarly, for this point, there is only one way to. There are two ways. So we can go like this or we can go like this. So the number of ways is 2. And for here we have 3 ways. Here 4, here 5, and here we have 6 ways. Basically, for every point you want to calculate the sum of the left and the down one. So I can say if dp of I and j is equals to a number of paths, then my transition will look something like dp of I comma j is equals to dp of I minus 1 j plus dp of I comma j minus 1, right? And using this we can calculate our solution in big O of n square. So I will just show you what the answer for this will be. Like here we will have a 2, then 3, no, it will have we will have a 5, then a 9, then 5 plus 9 plus 5 is 14, then 20. We don't even need to go beyond 5, right? Then we have 5, then 14, 28, then we can just take a sum of 14. 14 3s is 42. I think I am correct. And so we have total 42 uh, correct paths to reach the point 5 comma 5. I mean, like, if we have 5 opening brackets and 5 closing brackets, then there are 42 permutations which will be valid subsequences, right? Or there is a bisection that if we start from point 0 comma 0 and we want to reach the point 5 comma 5, there will be 42 different paths to reach the point 5,5. I mean, it will be 42 if I did not make any calculation mistakes in while making this grid. Okay, but this is an O of n square solution, and if our input is in range of 10 raised to power 6, this will not work, right? And that is the problem here. In this problem, we have our input is in range of 10 raised to power 6, so we can't use this solution yet. So we want to find a better solution. Like by now, I think you can think like this, that okay, the number of closing brackets can represent the going right, and number of opening brackets will represent going up, and we can convert this problem into this grid problem and visualize this. Okay, so instead of directly counting the number of paths from 0 comma 0 to n comma n, let's try to generalize this. So for n comma n, let's let me rub this. Okay, okay, now we want to, so instead of directly trying to count from 0 comma 0 to n comma n, why not first we what we can do is we can convert this problem into a subtraction. Like we can first find the total paths from 0 comma 0 to n comma n, and this will include even the bad paths which will not be valid. Basically, we will be moving even one step further from the red line. Okay, and if we are able to calculate this using permutation and combination, which we will see we can, and then we will try to find out the number of bad paths, and then we will just subtract these two and we will get the number of good paths. Okay, so that is our approach. And so how can we actually find it? So first, let's not get into the number of bad paths. First, let's just try to find out the number of paths. Okay, so we have 1 2 3 4 5, and we want to reach this point 5 comma 5. And one way is simply to make all of these ones, and here we will have also ones. And now you can just keep taking the sum of the previous two values, and using dynamic programming you can calculate the number of paths in big O of n square. But we will not do that. There is a simple observation here that okay, let me use a laser for this. Uh, let's try to take any random path. Like okay, one move will be this, then let's try to go up. 1 2 3 4 5 6 7 8 9 10. So it took 10 moves to reach there, right? And let's try to take another random path. 1 2 3 4 5 6 7 8 9 10. So we took another random path and we were able to reach this in 10 moves. Okay, now any you can choose any path, like 1 2 3 4 5 6 7 8 9 10. Right? So what we observe is that if we want to reach from 0 comma 0 to 5 comma 5, it will always take equal to, the number of moves will always be equal to 10. Okay, and from that, so that is our first observation. Our first observation is that the total number of moves is equals to n plus n, which is equals to 2n, right? And like out of these 10 moves, let's see, I'm not talking about the valid paths, I'm talking about all paths, right? So let me try to make an arbitrary path. Like I'm just making a random path. Okay, so this is one path, and let's try to make another path which will be very similar to this. So we have two paths here, and if you try to count the number of right movements, Like what I want to do is just count the number of right movement. There was one here, two, three, and four, and five. So out of these 2n steps, we took the number of right steps were five, and even on this path, like one, two, three, four, and five. So basically, the number of paths from 0, 0 to 5, 5 will be, I can take 2n steps, and out of which I have to select five points where I am going to take right turn. Or what I can do is I can take the up turn also. That is also equal to 5. So out of my 2n points, uh, I just want to select the n points and take either right turn, which is also equal to, out of 2n points, I want to select n points and take the up turn, right? So this is how we can find the total number of ways from 0, 0 to n, n. Right? So let me just write it somewhere for convenience. The total number of ways from 0, 0 to n, n is equals to 2n cn. So I hope you were able to get this, and I tried to clarify it as much as I could. Okay. So now that we are able to reach from 0, 0 to 5, 5, we just need to remove the number of bad paths from this, right? And like if you read the Wikipedia, okay, I close the tab, you can go there again and try to read it. I think it was the fourth proof or the fifth proof, I don't remember. So I will be using that trick to find out the number of paths. So for that, let's try to analyze using this grid. Let me just copy it because I don't want to ruin it. Yeah. So let's do our analysis somewhere here. Basically, we want to start from index 0, yeah. So we want to start from index 0, 0, and we want to reach 1, 2, 3, 4, 1, 2, 3, 4, 5. We want to reach 5, 5. But there is an issue here that now that I already know the number of good paths, I just need to calculate the number of bad paths. And and the proof is that I don't know the exact intuition for this, but we just make this diagonal for now. I can start from 0, 0, keep going point. Okay, and this is line y is equal to x. Now, like what will like if I check the number of points where a solution is invalid, is this big triangle, right? But my first what I should say, my first disturbance, or my first point where the path will become invalid will be one of these points, right? So my path can go from anywhere, like it can be valid till this point, and then suddenly it moves to one of these points and the path will become invalid, right? So what I can do is, since this line is very special to us, I will mark this line also. Line is so this line is y is equals to x plus 1, and this line is y is equals to x. Okay. Now we want to calculate the number of paths which at least once intersect this line, right? And to do that, there is a reflection technique. Uh, okay, so let's try to make a random path which was an invalid path. Like, okay, first I will go up, so to make it this invalid, and then let's say I went, I came back into the zone, and I made a path from till 5, 5, and this is an invalid path, right? So the trick says that consider this y is equal to x plus 1 as a mirror, and take the mirror image of this path. So we went from to right, so now we will try to take the reflection of this line. So three times up, then one time right, then one time up. I think I made some mistake somewhere. Okay. So it went three times up, three, one, two, three. Then it went up, so I will move one right. Then it went right, so I'll move up. 1, 2, 3, 1, 2, 1, 2, 3, 2. Then it went up, so I will go right. It went right, so I will go up. Then it went two times up, so I will go two times right. And you will see we reach this point. We reach this point, which is exactly the reflection of this 5, 5. So let's try to make one more line, one more path which was invalid. So let's try to construct one of the paths. So this is an invalid path. And if I take the reflection about this y is equals to x plus 1 line, it will be like, okay, so this is the point of reflection. So we have to, from here, like till this point, we don't need to take reflections. And from here, if I take the reflection, it went up, so I will go right. Then it went right, so I will go up. So we again reach this point, 4, 6, right? So basically what we see is that whenever there is an invalid path, if I take the reflection from this y is equals to x plus 1 line, it will always end up at this point. Suppose this was point n comma n, so this point will become n minus 1 comma n plus 1. Basically we are taking one more, at least one more right, at least one more up, more than the number of rights, right? Like that you have to imagine. So I can say that, okay, the number of invalid paths will simply be equal to the number of paths from 0, 0 to reach this point. That is n minus 1 comma n plus 1. And from the previous formula, like we can say that, okay, to reach this point, obviously the number of uh, turns is equals to 2n, right? You can try to make a random path again if you want to. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think there are 1, 2, 3, 4, 5, 6, 9, and one more 10. Sorry about that. Yeah. So even to reach here, the number of paths is still 10, and to reach 5, 5, the number of steps are 10. So out of these, basically we just are trying to sum the x and y values to reach a point. So basically will just sum it. So n minus 1 plus n plus 1, which is 2n, and we want to take n minus 1 right turns, or we want to take n plus 1 up turns. So that will be the number of bad paths. So this is the number of bad paths, right? And from here we can say that, okay, so what are the total number of good paths? It is simply the difference of these two. So we will simply do 2n c n minus 2n c n minus 1. So I hope you were able to get that. Okay. So I can say that, okay, nth term of the Catalan number. This series is called Catalan numbers. It starts with 1, 1, then 2, then 5, and then 14, and so on. Okay. So if you simplify this, actually, if you open it using the formula NCR is equals to n factorial r factorial n minus r factorial, and try to combine a few terms, you will get 1 upon n plus 1 2nc, right? So nth term of Catalan number is given by this formula. It should be 2ncn. Okay. And still, how can we model our solution in O of n? If you want to do that, what you can do is take the ratio, like just take the ratio of Cn and Cn minus 1, and if you take the ratio and open this, you will get 4n minus 2 upon n plus 1. So there is a recurrence relation between the Catalan numbers. It is Cn is equals to 4n minus 2 upon n plus 1 into C of n minus 1, where C0 is equals to C0 is equals to 1. And from here you can simply calculate C1, then put C1, then you can calculate C2, and so on. So this is using this solution and dynamic programming, you can calculate the nth Catalan number in big O of n, right? So that is good. Now you should be able to solve the this bracket subsequences problem using dynamic programming. But we have another problem here. Uh, in this, we are given a task where we already have a valid prefix. I mean, it might not be valid, but we are already at some point, like it is given open, open, and close, and we want to reach the same point n comma n. Okay. Huh. So how can we do that? Like, okay, this grid is also used. Okay. Let's try to see it on this grid only. So basically the problem is we are already given some sequence like opening brackets. uh, I think this was in the question, right? Okay, so we can say okay, plus 1 and minus 1. So we are starting with 2 comma 1 point. So 1 0 1 2 2 comma 1, this is the point we are starting from, and we want to calculate the number of ways from 2 comma 1 to n comma n, whatever is the n. In this case I think the n is 3, because 6 are the total number of pairs left bracket and right bracket. But we want to reach so basically from 2 comma 1 it is asking me to calculate the number of points to uh, 3 comma 3. So 1 0 1 2 3. So it is asking me to calculate the number of ways to reach from this 2 comma 1 to 3 comma 3, and that if you calculate it using simple dynamic programming, you can calculate that will be equal to I think 2. Yeah, and the condition is the same. You can't go above this line, but you can touch this line. So how can you calculate this? The same O of n square approach will work. Like you can start putting ones here, and then there's put all of these zeros. So the sum of this will be 1, then 2, and 2. So that is how you can reach this point in two ways. Okay, but that is an O of n square approach, and we can still do better, right? And how can we generalize this for any number of n? Hmm. So the idea is simple, that we will still do the same thing. Like we can calculate the number of ways to reach from this point to n comma n. Like, okay, let me write it on another page. Okay, suppose we are at some point x comma y, and we can only make right or left moves. Let's say here is the line, Here is the line y is equals to x, then there is also the line y is equals to x plus 1, and there is somewhere there is a point n comma n. Okay, and like just like in the previous problem, we can generalize this to, okay, just count the number of ways from x comma y to n comma n. Okay, and then we can count the number of ways to this point, that was n minus 1 comma n plus 1. Okay. So just count the number of ways from this to this, like total number of ways, and then count the number of ways to this point, that will be my bad ways, and take the difference, which will give me the answer, right? So how can we do this? Like how can we calculate? So this is simple. Like if I want to go from x comma y to n comma n, how many right turns I have to take? It will be the difference of this n and x, right? So I can say to reach n comma n, the number of right turns is just, okay, I should say, okay, the number of right turns is n minus x, and the number of up turns is n minus y, right? And so what are the total number of points in my path? It will be like 2n minus x minus y. And out of these 2n minus x minus y, I need to select n minus x right ways or n minus y right ways. So my total number of paths will simply be 2n minus x minus y c n minus x. And this is also equal to 2n minus x minus y c n minus y, right? So these are my total number of paths, and if I want to calculate the distance from x comma y to n plus 1, n minus 1 comma n plus 1, we can still calculate it. Like what are the difference? It is still 2n minus x minus y c. What is the difference between the x terms? It is n minus 1 minus x. So n minus 1 minus x is equals to 2n minus x minus y c n plus 1 minus y. So these are my bad ways. So these are my bad ways. Okay. And now you can just take the difference of these two, and that will give you the answer. So I hope you were able to understand this approach of converting this uh, bracket problem into a grid problem. Actually, there are many ways to visualize this. There is also a way to, like, we can, it is the same problem for counting the number of binary trees. Uh, like given n nodes, how many number of binary trees you can make, or if you count the number of mountain ranges. I mean, these all follow this sequence. Okay. So basically, if you are given a problem based on Catalan numbers, you can always convert it into this grid problem. And I just find that this grid visualization much easier than the other visualizations. So I wanted to discuss how you can actually calculate it. So this is how you can simply reduce the problem to big O of 1, right? If you can calculate the CN and pre-calculate the CNs, then you can reduce it in big O of 1s. Now I will just show you the code of both the problems. I mean, you won't even understand it, but basically I'm doing the same thing. I am pre-calculating uh, so I'm basically calculating the value of this I'm using this recursion. Like I'm putting my first value is 0. I think my first value was 1. Yeah, so my first value is 1, and then I'm using this sequence 4n minus 2 upon 4n plus 1 to calculate Cn. So that is why we have a loop of n times, and then I'm calculating it. Okay. Then for the bracket subsequences too, Yeah, here you can actually calculate the factorials and inverse factorials, and there is this formula for NCR. And there are very several corner cases, like even if the currently given string is already invalid, you can't be above the line and calculating the number of bad paths, right? So you need to check the number of if you were already invalid before, and if that is the case, you just need to print 0, right? Take the prefix sum and print 0, and after that it just follows the same procedure. Count the number of total ways using 2n minus x minus y, and then count the number of bad ways using this formula here, and just subtract these two, and that will give you the answer, right? So I hope I was able to contribute, and sorry, I hope I was able to add some value using this video. Thanks guys, I will see you guys next time.